distribution, and we're doing some word problems based on the normal distribution. So the first one I'm doing from exercise 8.4 is number 1. We know that IQ scores are normally just distributed and are measured on a scale that has a mean of 100 and a standard deviation of 15, and we've got to find the IQ x, which is exceeded by only 5% of the population. So I'm going to write down the stuff that I do know. First of all, I know that the mean is 100, so mu is 100, and I also know that the standard deviation is 15, and I want to know x such that it's only exceeded by 5% of the population. Now what I'm going to do at this point is I'm going to quickly sketch a graph of a normal distribution. This is my mean here, and the point that is exceeded by only 5% of the population is here, which means we've got a 0.95 percent or probability underneath that, and this should ring a bell. This is one of your critical values. So if you go to this section of your chart here, critical values for the normal distribution, you find P is 0.95, that means 0.95 underneath, and that gives me 1.645. So I know therefore that Z is 1.645, and now I can find X. Remember our formula for standard normal distribution is our Z number is equal to the X value subtract the mean divided by the standard deviation, and now we can just chuck these things in. I've got 1.645 is equal to X minus mu, which I know is 100, divided by 15, and I'm just going to rearrange these. 15 times 1.645 plus 100, and this is giving me X is equal to 124.7 or 645 or something. Oh no, sorry, 675, or maybe I could just say 125 to 3 significant figures, and that's my first one. The next one that I'm going to look at is number 5. Right. The operational life of batteries produced by one manufacturer A is normally distributed with a mean of 43 hours and standard deviation of 4 hours. Okay, and I've got to find the probability that a random battery, a selected battery, operates for more than 40 hours. So let's write down what we know. We know that the mean for how long a battery lasts is 43 hours. This is company A. We know that the standard deviation is equal to 4. We want to know the probability that the battery lasts longer than 40 hours. So our X value is equal to 40. So let's find our Z number. Z equals 40 minus 43 all over 4, and what does that give us? Well, we've got 3/4, so that's going to be negative 3/4 or negative 0.75. Okay, we want to find the probability, we're being asked to find the probability that a randomly chosen battery operates for more than, so with probability that X is greater than 40. Okay, now let's just quickly sketch our normal distribution curve here. That's Z is 0. We have a negative 0.75 here, and we want to know this bit here. Goodness gracious me. Okay, so if we want to know that bit there, you can see that that is the mirror image of if we found phi 0.75 here, which would give us all of this, which is what we want. The blue and the red will be the same. So I can say the probability of X being greater than 40 is equal to phi 0.75. So go to 0.75 for your Z value, 0.7, go across to 0.75, and it's 0.7734 equals 0.7734. Okay, perfect. That's part 1, part A. Part B. What length of operational life is exceeded by 10% of the batteries? So what we're looking at is we're looking at this point here where we've got 0.9 is underneath. So this is not a Z number. What I'm writing here is a probability. A probability that 90% is under and 10% is over. Okay, so the Z number here, I'm going to look at my critical values, because critical values will help here. I know that Z value for 0.90 probability is 1.282. So there we go, that's our Z number. Now what is this value here? I need to find what X is, whatever X would be when Z is 1.282. So perhaps I could pop that in my formula here. 1.282 is equal to X minus my mean 43 over 4, so I'm using this again, and that gives me 4 times 1.2 4 times 1.282 plus 43, and I'm getting the wrong answer by the looks of it. I've typed something in wrong. Plus 43, that looks much better. 48 point. So X is 48.128. Okay, so this point here, where 90% is below and 10% above, is 48.128, and that is the length of operational time. That's all I need to say. That is the length of operational time at which 10% will be above and 90% will be below. Okay, now the last thing from number 5 is we've got a rival manufacturer. I'm just going to rub this out. We've got a rival manufacturer, and they, we'll call them B, shall we? And they have the same standard deviation. What else do we know about them? They want to be able to claim that 95% of their batteries last longer than the average produced by the manufacturer A. Okay. In other words, 95% of their stuff is greater than the mean of this one. Okay. Well, in that case, we know that we can figure out our Z number, because if 95% is greater, that means 0.5% is lower, and so our Z number in this case is going to be negative 1.645. Now you might be thinking, what the heck how did you get that, right? Okay, go to your critical values. You know that 95% is 0, is 1.645. Okay, that's it. 95% is below and 5% above. Now, thing to remember about your normal distribution curve is that it's symmetrical. So you're going to have the negative Z number here. That means 5% will be below and 95% above. So that's how I got this. Now that Z has to occur when X is equal to 43, which is the mean from the first one. Remember, we want 95% being greater than that. So this Z number and this X have to go together, and now we've got everything we need to be able to find the mean of this new company's battery life. So Z equals X minus mu all over standard deviation, and I can just pop in the numbers I know. I know negative 1.645 is here. I know that X is 43, and then I know that, well, I don't know the mean yet, but I'm going to find it out, and I know this is 4 again. Now I'm just going to put all of that together, and when I do put all of that together, let me see what I get. So 4 times negative 1.645 minus 43 times negative 1. I'm getting 49.58, or 49.6 hours would be my answer. That would have to be the mean battery life of company B in order for 95% of its batteries to have a greater life than 43 hours. So I'm just going to do one more of these questions from the exercise with you, and then I'll let you try a few on your own, and you can email me if you get stuck. Number 8, a company employs a large number of administrative staff, and when the company wants to employ new staff, candidates are given a standard task to complete, and the time they take to complete the task is recorded. It's observed that the times taken by candidates are normally distributed with a mean of 360 seconds and the standard deviation 75 seconds. What proportion of the applicants take longer than 450 seconds? Okay, here we go. So, what do we know? We know the mean. We know the mean in this case is, what did we say? 360. We know the standard deviation. The standard deviation is 75. We're looking at X is 450, and we want to know people that take longer than that. Okay, now obviously it's greater than the mean, so 450 is somewhere over here. We want to know this section here, the probability. So obviously we're going to need to find a Z number for this. So I'm going to go Z equals this minus this, so 450 minus 360 all over 75. What does this give me? 90 over 70, was that wrong? What is it? 90 over 75, is that right? 40, yeah, 90 over 75, which is 1.2. Okay, so Z is 1.2. So now I go to here. I find Z 1.2, and I get 0.8849. But if I want probability that X is greater than 450, remember, if I just look up Z 1.2, I'm going to actually get from here, I'm going to get this probability. So I want to go 1 minus phi 1.2, which is 1 minus, now phi 1.2 according to my diagram here is 0.8849, I think. Okay, and when I do that, I'm going to get 0.1151. Okay, cool. Now that's the first part. What proportion of applicants take between 210 seconds and 450 seconds? So, probability, I'll do a different colour here maybe. Probability that we've got 210 is less than X is less than 450. Okay, so 210 is obviously less than the mean, so we're out here somewhere. We're wanting to find this bit here. Okay, first of all I'm going to find a Z number for 210. So Z equals 210 minus 450, oh not 450, 360 is our mean, isn't it? 360 over 75, and that gives me a Z number of minus 2. So this is minus 2, this is 1.2. So I can write this as equals phi 1.2 subtract phi minus 2. Okay? Phi 1.2 gives me everything that way. Phi minus 2 would give me everything that way. But remember, your table doesn't give you negative Z numbers. How do we express a negative Z number? Well, we know that phi negative 2 is this part here. And if we go up to 2 here, if we get 1 minus phi 2, because phi 2 would be everything that way, 1 minus phi 2 would give us this here, which will be the same as that there. So another way of writing this will be phi 1.2 subtract 1 minus phi 2. Now, phi 1.2 we found to be 0.8849. And then phi 2, if I look this up on here, 0.9772. And this gives me 0.8621. Okay, and the question was, what proportion of applicants take between 210 seconds. So we could say that's 86.2% of applicants, or 86.21% of applicants. Okay, what is the time exceeded by 5% of the applicants? Okay, so first of all, in part 3, or is it C? Part 3, Z number. If we're looking at, dear oh dear. We're looking at 5%. So that's 5% there, which means 95% there is. So we're looking for a Z number, which gives us 0.95% below. So you go to your critical values as per before, and I'm getting 1.645, so that's 1.645 there. So Z equals 1.645. Okay, and then we can find out what X is by chucking this into the formula. So we'll have 1.645 equals X minus our mean, which is 360, over our standard deviation, which is 75, and then we can go and figure out what X is. So if we just plug this into our calculator, 1.645 times 75 equals plus 360 equals, I'm getting 483.75. 483.75 seconds. Maybe 44 seconds to 3 significant figures. Okay, the last thing. Okay. So, candidates who take longer than 450 seconds are rejected, and candidates who take less than 210 seconds are automatically accepted. The remainder are interviewed. Okay, so maybe we better sketch this on our normal distribution. Okay, here it is. Okay. This was 210 had a Z number of minus 2. So this part of the graph is automatically accepted. Auto accepted. No interview required. And then at the other end, here's our mean here. At the other end, we had at 1.2. These guys, unfortunately, over here, these guys are rejected. And this white bit in the middle, they are interviewed. And we are trying to find the median time taken by those applicants who are interviewed. So the median time of this group here. Now, first of all, the first step in this is to go, well, what is this represented by? And we found this up here. This is 0.8621 of the spread of data, 0.8621. So what is halfway of that? Is 0.43105. That's halfway of this, okay? But to find the median of this data, we need to be able to look something up on our table, and 0.43105 is of this here, which is not the normal curve. So we're going to add this on here, and that will tell us how far we need to go from here. It'll give us some useful data. So the auto acceptance would be, the percentage will be this bit here, 1 minus 0.9772, which is phi negative 2. We did this earlier. So what is 1 minus 0.9772? I'm getting that to be 0.228, I think. Is that right? Yeah, so this bit here is 0.228. Okay, so if we start here, and we want to find the median, we go 0.228 plus 0.43105. What does that give us? 0.43105 plus 0.228. That's giving me, no, not 0.228, sorry, my bad. It is it is 0.0228 because it's only a 2.2% chance, right? So it should be, do that again, 0.43105 plus 0.0228. And that's giving me 0.45385. So, the median of this group that are interviewed is going to be at a point where 0.45385 are underneath it on the normal curve. So all I'm going to do now is go, alright, where is that? Now the problem you'll straight away see is that, I'm just going to rub a bit of stuff out here, the problem you're going to see straight away is that your Z numbers start at 0, but we don't, 0.5, so your probability start at 0.5, this is 0.5, we're slightly under that, this is somewhere here, right, that's there. So what we need to do is find the same place on the other side, and if we want to find this blue bit here, so we can find that, or we want to find this value here, we just find the Z value here, and this will be the negative Z value of it. Okay, so all I'm going to do is I'm going to go 0.5 minus 0.45385, and that's giving me 0.04615. So I'm going to go 0.5 plus 0.04615, which gives me 0.54615, and I'm now going to find a Z value for that. Okay, now this is a bit tricky. The closest I can get is Z number 0.0.11, and that gives me 0.5438, which is not quite there. So how am I going to get to this one, 5438? I need to add 24, that's the closest I can get, which is 0.0, so the Z number would be 0.11, and then add 6, add 24, 6. So that's what I think my Z number is. And that means that this Z number here is negative 0.116. If you're not sure how I got this value here, I can't really show this on the camera very easily, but I want to find 0.54615. I can see that Z1.11 is 0.5438, and then I've got to add something to get from 0.5438 to 0.5461, and the closest I can do is by this column here where it says add, and I'm going to add 0.0024, which gives me my third decimal place is a 6. Hope that makes sense. So that's this bit here. So therefore this bit here is going to be the negative Z value by symmetry. And now we can find out the median of this area here. So we go Z equals X minus mu all over sigma. We pop in our numbers. Negative 0.116 equals X minus mu, which was 360, all over sigma, which happens to be 75, and then I find X equals, just going to chuck this into my calculator, and I get 351 seconds. And that is the answer. So what is that 351 seconds? The 351 seconds is the median time taken by those who are interviewed. Well, I hope that helps you get on your way. Some of these require a lot of thinking, If you do get stuck, of course, ask, and I will be able to either Zoom with you and explain something, or maybe do another video. Alright, good luck.